My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 531. In this lecture, we will try to understand how biological neuron works. Let's understand how biological neuron work. It is a simplified version of how biological neuron work. So, given that idea, we can now extrapolate that into mathematical model, that is artificial neuron. First, let's start with simple biological neuron. It has a cell body, this is and nucleus. It has lot of dendrites. It has something called axons, isn't it? These are three key elements of a biological neuron. Just see this one. Let's represent cell body with a circle. Just if you observe, in biological neuron, dendrites are similar to input in artificial neuron. Axon in biological neuron is similar to output. Synapse in biological neuron is similar to interconnection. Cell is similar to node, isn't it? Just see, this one is biological neuron, this is artificial neuron. Dendrites, these dendrites inputs is similar to inputs of a neuron. Cell body, this is cell body, is represented by circle. These outputs is represented by axons, isn't it? Yes. What does it mean? These let's represent dendrites as edges. These are known as dendrites, inputs of this neuron, isn't it? And edges with directions like this. These are the edges direction, and axons with edges going out from this axon. Axon means it's going out from the neuron, isn't it? It's going out from the neuron. That is axon. This is very simplified view of biological neuron. Of course, it has lot of internal chemical reactions and electrochemical reactions. We are looking at most simplified view of it. These are as we were saying, these are dendrites, and these are this one is axons. Axons can go ahead and connect it to other neuron. These axons are output of this particular neuron. This will be connected to other neuron. This particular neuron could be connected to other neuron here, isn't it? First we will look at view from one neuron. First we will try to understand this view from particular one particular neuron, isn't it? First we will look at view from one neuron. Some dendrites are thicker than other. For example, here what happened? This particular dendrite is thicker than other dendrites. Basically, if some dendrite is thick, that implies that there is a more weight for it. So, what is the mathematical model of a neuron? Mathematical model of a neuron is there is a function f. There is a function f here. There is summation followed by a function here, isn't it? Here, this one is summation. What is this? This one is summation followed by function. We saw this earlier. There is a summation follows by a function here. Let's assume this x1 is dendrite. This what is this? X1 is dendrite. X2, X3, X4 for sending signals. You can send the signals through dendrites through these dendrites to this particular neuron. Since some signals matter more, there is a weight associated with every dendrite. There is a weight associated with each of them. W1 is a weight associated with x1. Yes, let me assume here W1 is weight. This is W1 is associated. This W1 is a weight associated with x1, isn't it? This is x1. W2, this one is W2 is associated with W2 is associated with input x2. So on W3 is a weight associated with input x3. W4 is a weight associated with the input x4, isn't it? A neuron, I can say this output. What is my output? Function of summation of I equal to 1 to n wi xi, isn't it? That on that one, that is for if you apply function on this summation, weighted summation, I will get output. This f is known as activation function. This xi, x1, x2, so on xn are inputs, isn't it? There are weights w1, w2, so on wn are weights. I can say a neuron is activated or neuron is fired if there is an enough input. This is cell. This one is cell, isn't it? Which one is cell? This cell, isn't it? This cell will be fired and send signal out. If there is not enough input, if there is not enough input, then cell does not send signal. Then the cell does not send signal. That's how a simple neuron works. This function f often referred to as activation function. This function f is often referred to as activation. F is often referred to activation function. If inputs has more weight, then it will be considered as thicker dendrite, isn't it? If input is more weight, then if some input weight is higher than other one, then I can say that is thicker dendrite. Some dendrites are thicker and some dendrites are not thicker. The output of the neuron is, what is my output of the neuron? Output of the neuron is f of summation of I equal to 1 to n wi xi. As we are discussing that xi, this xi I equal to 1 to n, what does it mean? This is x1, x2. If I equal to 1, I will get x1. If I equal to, I will get x2. If I equal to 3, I will get x3. If I equal to 10, I will get xn. All these are inputs. If I equal to 1, I will get w1. If I equal to w2, w3, so on. These are corresponding weights. It is essentially, what is this this particular summation? w1 x1 plus w2 x2 plus so on wn xn. On top of it, we are applying a activation function f, so that I will get output. If this particular neuron, yes, here the same output, here it is, this neuron is generating output. The same output O will be sent through all axons. This O is same here. Through all axons, through all outputs, the same output O is transmitted through each of these axons, or through each of these outgoing edges. We will learn in my next lecture. We will learn perceptron and logistic regression as a simple neuron in my next lecture. By that time, just I request all of you go through this particular output function. As I told you, the same output O is transmitted through each of these axons, or through each of these are known as axons, isn't it? Each of these axons are outgoing links. We already defined what is output here. We are repeatedly saying output, same outputs, f of sigma I equal to 1 to n wi xi. This is weighted summation of this one, x1, x2, xn. We already discussed x1, x2, so on xn are inputs, w1, w2, so on wn are weights. F is an activation function, O is output. This neuron generates output. The same output will be sent through all the axons. That's important point. That's what I am saying. The same output O is transmitted through each of these axons or through each of these outgoing edges. Thank you very much.